Next one is to draw the bending moment diagram. Now, one thing you're going to do is that you see this part where this shear force diagram, where it cuts the x-axis, project that line. Project that line downward. Yeah, you need it. Exactly. Good. Now, after that, let's go. Remember, the area under the shear force diagram give us the bending moment. Now, look at this. What shape is this? This is a triangle. Now, the area of this will give me the value of the what? Of this bending moment diagram. Now, let's go. What's the area of this one? Remember, half base times, I look at my calculator, half times the base is 1 and the height is what? 10. And that is what? 5. So that is 5 kilonewton watt meter. And remember, check, I said something that whenever you have a constant line like this in your shear force diagram, your bending moment diagram will actually slope. But now, if your diagram like this is sloping, your bending moment diagram will be a parabola. Are we together? It should always be like 1 degree higher than this. Let's go. Now, this is a straight line, so you are going to draw a parabola. So you are going to draw this parabola like this. So you need to draw this parabola exactly. So this is how it should be. So remember, this one is sloping, this will be a parabola. So, and remember, what's our value? 5 kilonewton meter. And this is where you have your highest point because that's where the shear force is 0. Now, next one is this. What's the area of this one that is here? Check it out. What's the area of this one? Check it. The area of this one is what? Half base times height also. Half times the base is what? 3. And the height is what? 30, or you can say minus 30, no problem. And that's what? 45. So you are going to remove that 45 from here because this is a negative, falling on the negative x-axis. So 5 minus 45, that will give me what? That will give me minus 30. So this one will come exactly. So to fall at what? Minus 30 kilonewton watt meter. Then after that, remember, what's the area of this part? This is a rectangle. Base times height, that's what? Length times breadth. So I have 20 times 2, and that will give me 40. All together, that will give me what? 40. No. Check. It's like this. So what's the area of this one again? Half times, what's the base? 3. What's the height? 30. That's 45. Sorry, 5 minus 45. This one should be 40. Sorry about that. So this one is what? 40. Exactly. Now, as this one is 40, remember, the area of this one is what? Length times breadth, 20 times 2, and that's what? 40. But it will be a positive 40 because it's above the x-axis there. So it is positive, and remember, this is a straight line. This one will be what? A line that will incline like this. So exactly. So remember, so 40 is positive. So I have minus 40 plus 40. That will stop at 0. Again, area of this one give me 5. You draw a parabola. Next one, area of this one is what? Minus 45. So 5 minus 45, I will have what? Minus 40. Area of this one is 40, like this. So that's that for that. Now, next thing is that what? How do we get our point of contraflexion? That point of contraflexion is actually where your bending moment diagram cuts your x-axis. Where the bending moment diagram is what? 0. When your moment says 0, that's the point of contraflexion you have to look for. Very, very simple. This is what you are going to do. The way I did this one, also do this one like that. Put your UDL to span and stop at that point. Remember, our UDL is what? 10 kilonewton per meter. And let me just say the point where this bending moment diagram is equal to 0. Let me call that point. Let me just use x. So remember, 10 kilonewton per meter times x will give me what? 10x. And that 10x will be placed somewhere here. So I have what? 10x. And remember, this 10x will be placed at the centroid of this line. Remember, this part from here to here is x. So it means that what? After getting, the UDL here is 10 kilonewton per meter times x will give me 10x. And that 10x will be placed at the centroid. If the whole length of this line is x, then the half of this one will be what? X over 2. So I have what? X over 2. And from here to here also will be what? X over 2. All together exactly. Now remember our sign convention. When I have a beam and I cut that beam like this, remember the shear force positive, but here I'm not talking about shear force now. Now, what do we say about the bending moment? If you are summing up all your moment to the left, just like the way I'm doing it like this, from here to the left, your clockwise moment is positive, while your what? Anti-clockwise moment is what? Is negative. Take note of that. So let's go. Now, I'm picking the moment about this point. So look at this force that is here now. Remember, it's producing what? Anti-clockwise what? Moment. And that will give me what? Remember, moment is force times distance. The force here is what? 10x times what distance from here to here? X over 2. Positive or negative? It will be what? Negative because it's anti-clockwise moment. Next one, the next force I have here is which other force again? This your 10 kilonewton, consider it. This your 10 kilonewton that you have here, consider it. So I have 10 kilonewton here. Remember, this 10 kilonewton is going upward, so it's giving me a what? A clockwise moment, which is positive. So remember, 10 times what distance from here to here? Distance from here to here is what? X. So 10 times x is what? 10x, right? So I have 10x. So I have 10x, right? And remember, the moment about that point is equals to 0. So from here I have this and this will give me what? Minus 5x squared plus 10x equal to 0. So I can just say factorize 5x out. That will give me minus x plus 2. And that's equals to 0. Remember, here x will be equal to 0, but it will be rejected. This part cannot be 0. The next one, minus x plus 2 equal to 0. So from here, x is equals to, okay. So remember, here minus x plus 2 equals 0. Here x will be equals to what? Plus 2 meter. So the point of contraflexion. So the point of contraflexion is what? The 2 meter. So that is it. So just understand this part very well. Understand this part very well. It's very, very easy. And understand the sign convention. Let me just recap that. If you cut a beam to the left, shear force upward is positive. The one downward is negative. Clockwise moment is positive. And clockwise moment is what? Negative. So you can go to the slide and solve more questions. Take care.